Hi, Algebra Honors. This is Unit 7 on polynomials. This is day 3, and so we're going to find the greatest common factor within our polynomials. So in effect, we're kind of dividing some of our polynomials. So first, we're going to multiply stuff. So just quick review, we're going to simplify the following polynomial expressions using the distributive property. So I'm going to multiply a times 3a, and also I'm going to multiply a times 7. So I get 3 times a, that's 3a squared, plus a times 7, which I'm going to write as 7a. Here I'm going to multiply negative 2m times every single factor inside the parentheses, and so I have negative 2m times m squared. It's going to be negative 2m cubed. Then I have negative 2m times 6m, so negative 2 times 6 is negative 12, and m times m is m squared. And finally, negative 2m times negative 1 is going to be positive 2m. Okay, so I am multiplying out, I am distributing a factor, and coming up with the product in simplified form here. Okay, this guy has a complicated first factor, but that's okay. 4x cubed times y, all times x squared. I know that I have 4 times 1. There's an invisible 1, right? So my number is 4. X cubed times x squared. I'm going to keep my base x and add 3 plus 2, so I get 5. And then times y. There's no other y, so I just say times y. Okay, now I'm going to multiply all of that times negative 2y. So 4 times negative 2 here is negative 8. X cubed times no other x's, so I keep it as x cubed. And then y times y, I have y squared. Okay, so I have multiplied using the distributive property and simplified my expression. So there's no math really to be done at that point. So what we're going to think about today is finding the greatest common factor. And factoring is the process of separating the polynomial back into its products. And sometimes there's more than one possibility here. So in this case, though, we're going to undo distributive property and find the opposite of what we would have done when we multiplied or distributed. So I'm actually going to choose I'm going to choose a trinomial to look at here. Okay, so if I have 30x cubed plus 5x squared minus 25x, what can I take out of each one of those terms? Well, the numbers that I have to work with, I have a 30 and a 5 and a negative 25. So I think 5 goes into each one of those. I'm going to pull a 5. I'm going to tell you right now that we like to have our bigger expression that we're talking about once we factored, we like for it to be positive. So I'm going to take a positive 5 out of here so that I will have positive 6x cubed. But later you might see me take a negative number out of the first term, and that's because I want my first big term to be positive. Right, I know 5 goes into each one of these terms, so I'm going to take a 5 out, right? What else goes into each of these terms? I have x cubed, x squared, and x. I can take an x out of each one of those. So if I imagined that I had distributed 5x into some trinomial to get 30x cubed plus 5x squared minus 25x, I can figure out what that trinomial would have been. I'm going to divide each factor here, or excuse me, each term here by 5x. I know 5x goes into everything. So if I took 5x out of 30x cubed, I know that 30 divided by 5 is 6, right? And x cubed divided by x is going to be x squared. If I took 5x out of 5x squared, you can imagine 5x squared divided by 5x. 5 divided by 5 is 1. X squared divided by x, is just x. And then my third term, I have negative 25. 5 goes into negative 25 negative 5 times. And then x goes into x once. Okay, so I have factored out my simplest form. This is my simplest form here. When I factored out what I could, I was able to pull a 5x out, and it left me with 6x squared plus x minus 5. I'm just going to double check and make sure that that really did work, and I'm going to distribute this back out again. So 5x times 6x squared, it's really 30x cubed. 5x times x is going to be really 5x squared. And 5x times negative 5 is negative 25x. Is that what I meant to get? 30x cubed plus 5x minus 25x? It is. Okay, so what that means, and this is like my workspace over here, that means that I was able to pull out 5x from each term, and I was left with 6x squared plus x minus 5. Okay, so things that are important to remember, you have to, if you take anything out of any one of these terms in this polynomial, you have to take that thing out of every single term. So be careful with that. And then you want to make sure there's no other factors in there that could be pulled out. All right, sometimes you'll get something like 3x minus 2 as an expression. That's a binomial, right? And if you can't find any factors to pull out, there's no factors except for 1, right? Nothing to pull out of there. If there's no factors that are common, then we call it prime. And if you think about it, that makes sense because a prime number, the only factors are 1 and itself. Okay. So there could have been a million different things that I could have started with a simplest form and breaking it into a factored form. So we're gonna just kind of move forward and do some examples and see how this kind of thing sticks, okay? There are different methods, just like there are different methods for us to multiply our polynomials together, there are different methods for us to factor. So the first thing we're going to do is try to factor out the greatest common factor. So we're going to identify the greatest common factor, and that's, you know, mostly thinking about your terms. You're going to check each one of the coefficients to see if there's a greatest common factor. So what's the biggest number that divides evenly into the coefficients of each term? When we did that, we said what number, what number divides into 30 and 5 and negative 25. Okay, and then we thought about our variables as well, right? So first we check our coefficients, and then we're going to look at our variables. And the variable, it has to be in every single term. Okay, so we're going to divide each term by that greatest common factor. Anything that's left over stays inside parentheses. And you can check your work by distributing it back out again. So here, 3x plus 12. Well, I have a constant and I have a term that has a coefficient and a variable. So in this case, I am going to look just at the number 3 and the number 12 and think, what goes into both of those? Well, 3. 3 goes into both of those. So I'm going to pull 3 out. Okay, so you can imagine I'm dividing by 3 here. I'm pulling 3 out. So 3 is on the outside of the parentheses. What do I have left? 3x divided by 3, I ended up with just an x left. 12 divided by 3, I ended up with 4. Okay, so when I pulled 3 out of each one of my terms, when I pulled 3 out of 3x and out of 12, I was left with x plus 4. Let's just check and redistribute and see. So check by redistributing, and I get 3x plus 12, and hooray, that worked. Okay, so when I look at x plus 4, I don't see any factors that I could pull out of there. 5x plus 30y, first I'm going to look at my coefficients, and I would say I can pull a 5 out, right, because 5 goes into 5 and 5 goes into 30, and now I want to look, what goes into x and y? Well, nothing, right? They are not common. So all I can do is pull out that 5. 5 goes into 5x, x times, right? Imagine that we're dividing by 5. Imagine that we're dividing by 5 because we're pulling a 5 out. 5 goes into 30, 6 times. And then I also have times y, right? So 5 goes into 30y. When I divide 30 by 5, I get 6, but it's still times y. I can check it using distributive. And so I get 5x plus 30y. Check. Here I'm looking, and the number that I can pull out of each of these is 4. I'm going to take a 4 out. Next I want to look and see what variable can I take out. Well, I have y squared and I have y. So you're going to go for the smallest exponent, and that's what you can take out of everything. So smallest exponent is y, is 1 right here, y to the 1, right? So I'm going to pull out y. And that leaves me with 4 divided by 4 is just 1. Y squared divided by y is just y. Okay, I divided that by 4y. Negative 24 divided by 4 is negative 6. And y to the messy 1 divided by y is just 1. Okay, so let's double check and make sure we got this right. We're going to check. 4y times y is 4y squared. 4y times negative 6 is negative 24y. 4y squared minus 24y. Looks like that worked. 5x minus 13y. 5 and negative 13, they do not have a common factor. X and y do not have a common factor. So this is it. I cannot simplify anymore, and I might just say that that's prime. Okay, so we are factoring by taking out the greatest common factor. And there's a little bit of just kind of thinking it through when you're doing that method. Okay, so we're going to keep trying. At this point, if you want to try some of these problems, put this video on pause and come back. You can certainly do that. So I have 21CD minus 3D. So I have 21 and negative 3. I want to keep the first term positive, so I'm going to pull out 3. Okay, if I pull out 3, then I'd be left with 7CD, and I'd be left with negative D. Okay, but when I look at my variables, I can see that I can also pull a D out of each of those, right? So I'm going to pull 3 and D out of each one of those terms. So I'm left with 21 divided by 3 is 7. CD divided by D is just C. Now I have 3 divided by 3 is 1, and D divided by D is just 1. Okay, check your work. So if I check it, I get 21CD minus 3D. 21CD minus 3D worked. Okay, 6a squared plus 27. Looking at the numbers, I can pull a 3, right? A squared, no a. So all I can take out is a 3, and that's going to leave me with 2a squared plus 9. Okay, here I have 16xy squared plus 28xy plus 8y squared. My numbers, 16, 28, 8. Looks like I can take a 4 out, right? Because 8 does not go evenly into 28, but 4 does. So I'm going to pull a 4 out, and then x, no x. So I can't take x out. Y, I can take y out of everything. So I'm going to say 4y is what I'm pulling out. 16 divided by 4 is 4. X is still x, and y squared divided by y is y. This term, 28 divided by 4 is 7, and then xy divided by y leaves me with just x. And finally, 8 divided by 4 is 2, and y divided by y is 1. If I check it, it's 16xy squared plus 28xy plus 8y. All right, 5x cubed plus 25x squared plus 45x. I see 5 is the biggest number I can take, and the lowest exponent I have is this invisible 1, so I can take an x out of everything. I'm going to pull 5x out, and that leaves me with x squared plus 5x plus 9. Each time what I'm doing is imagining that I'm dividing every term by 5x. Right, so 5 divided by 5 is just 1. X cubed divided by x is x squared. That's how I got that term. 25 divided by 5 was 5. X squared divided by x was x. And here 45 divided by 5 was 9, and x divided by x was just 1, not any x's, right? Or it's x to the 0. Okay, 2x squared y minus 2xy squared plus 4xy. Well, with the numbers, I'm going to pull a positive 2. And my letters, my variables, x squared y, x, y squared, xy. I'm going to pull xy from everything because there is an x and a y in every term. That leaves me with 2 divided by 2 is just 1, x squared divided by x is x, y divided by y is just 1. Negative 2 divided by 2 is negative 1, so x divided by x is 1, and y squared divided by y is just y. 4 divided by 2 is 2. And xy divided by xy is just 1. So that is my my factored out answer. Okay, 12 a to the 5th b squared minus 36 a to the 4th b cubed minus 6a squared b squared. Sorry, that's hard to read. I had to pull it over close to me. All right, my numbers, 12, negative 36, negative 6. I am going to pull a positive 6 out of everything because I want my first term to be positive inside the parentheses, okay? I'm going to pull out a 6 and then look at the a's. I have a to the 5th, a to the 4th, and a squared. I can pull a squared out of everything. So I'm going to say a squared, b squared, b to the 3rd, b squared. So I'm going to divide everything by b squared. Everybody at least has b squared. Okay, 12 divided by 6 is 2. A to the 5th over a squared. It's going to be a to the 5 minus 2, so it's a to the 3rd. B squared divided by b squared is just 1. My next term, negative 36 divided by 6 is negative 6. A to the 4th divided by a squared is going to be a squared. And b cubed over b squared is b. And my last term, negative 6 divided by 6 is negative 1. And then a squared divided by a squared is 1. B squared divided by b squared is 1. So all I get is 1 there. Okie dokie. 3x to the 4th minus 9x cubed minus 12x squared. So I'm going to take a 3 out of everything. And my smallest exponent on an x is that 2. So I'm going to take x squared out of everything. 3 divided by 3 is 1. X to the 4th over x squared is x squared. Negative 9 divided by 3 is negative 3. X cubed divided by x squared is x. Negative 12 divided by 3 is negative 4, and x squared divided by x squared is just 1, so that's it. 4x to the 5th minus 24x cubed plus 8. When I look at my numbers, 4 goes into each one of those numbers, the coefficient or the constant. So I'm going to pull a 4, and then I have x to the 5th, x to the 3rd, and no x's, so I'm not taking any x's out. That leaves me with x to the 5th minus, let's see, 4 goes into 24 6 times, so minus 6, x cubed plus 8 divided by 4 is 2. And finally, 13a squared bc minus 3abc squared. So first of all, those are not like terms, so I couldn't just simply subtract. 13 and 3, or 13 and negative 3, either way you look at it, no common factors, right? But I can pull an a and a b and a c from everything. So I'm going to pull a and b and c out. That leaves me with 13a, right? 13 divided by 1 is 13, a squared divided by a is a, bc divided by bc is just 1. Okay, minus 3, a divided by a is 1, b divided by b is 1, and c squared divided by c is c. So this is the factored form. This ABC times the quantity 13a minus 3c is the factored form of 13a squared bc minus 3abc squared. All right, so I'm going to end this video here and start our next video on, this is again Unit 7, Day 3, and we're going to divide by polynomials in the next video. Thanks for watching.